Okay, perfect. Hi everyone. My name is Roger Willis, and I've been spending a lot of time recently working on tokens. Now, tokens is a pretty vague and high-level name for actually what I've been doing, but fear not. In the presentation, we'll get into some detail around what kind of things I've been looking at and what kind of design decisions and changes what kind of design decisions I've had to make and what kind of changes I'm looking to propose to make to the platform to meet all of our customers' requirements. So that's where you guys come in, really. So what I'm going to present to you today is a high-level overview of what I've been doing for the past couple of months, and it's just a proposal, really. Nothing set in stone. It's not concrete, and we'd very much like your comments on it. So really, the objective for this review is share our ideas. Now, we've already worked on some of this stuff with the guys from Corda. So Fuzz, who some of you may know, has actually already reviewed this proposal. He's sitting in the room next to me. But we'd like to get some feedback from you guys as well. In particular, we'd like to know if we have missed or forgotten any particular requirements, or whether the proposed design or proposed approach impedes you guys from doing something that you would like to do. So that's the last bullet point. Identify any blockers for you guys. So that's it, really. So let's begin with what we're actually looking to do going forward. So as you may know, in the Corda repository to date, we have something called the finance module. And inside the finance module, we've defined a cash state and contract, an obligation state and contract, some flows for using cash states, and some various other assorted bits and pieces that are probably not really very useful, to be honest. So what we'd like to do is actually deprecate this finance module and publish a set of standards for using tokens on Corda. So these standards will be analogous to the ERC, to the Ethereum ERC standard. So the likes of ERC 20 for fungible tokens and ERC 721 for non-fungible tokens. Obviously, in Corda, things are a little more complicated. So we don't just have there's some contract code representing the token. We need to define states, various other data structures and flows for using these states in transactions as well. So we'll be looking to release all of that as standards at some point in the near future, and as well produce a tokens SDK, which will really just be a set of high-level types, so interfaces, abstract classes, abstract flows for you guys if you want to build Corda apps that use tokens. And as I said, we'll probably end up deprecating the finance module, but that won't be for a while because I'm aware that some people are still actually using it. Any questions so far? Okay, great. So I know we always say this in the Corda white paper. We bang on about everything being an agreement, and of course it is, and it's not actually self-evident to a lot of people that use money and securities, right? Because if you think about cash, you have coins or notes or whatever in your pockets, and in your brokerage account you have securities that you own. Yes, you do own them, but actually those securities and that cash is really just an agreement with another party. So if we take cash, for instance, what is the money in your bank account? Well, it's actually a liability of your commercial bank, the bank that you bank with, to deliver a liability of the central bank, which initially was actually for the central bank to deliver some gold, but since we've broken the gold standard, there's actually some kind of weird circular relationship between the liabilities and the asset side of the central bank's balance sheet. But let's ignore that for today. That is very much out of scope for the purposes of this discussion. All I'm trying to demonstrate is that everything on Corda is an agreement. Now, if you have a share, then what does that share represent? Well, it's that the share certificate confers rights to you as a shareholder to receive cash flows from the company in the form of dividends, and that share certificate has a value based upon the present value of all the future dividends that the company makes. You also might get some voting rights as well. If you look at a bond, what is the bond? Well, the bond indenture is just a legal agreement that gives you rights to cash flows, and it gives you a senior claim on the company in case it's wound up, right? So all these things are just agreements. And to be honest, I think the word token is kind of misleading, because token to me implies something that is not an agreement, but maybe that's just me. I guess what I'm trying to get to with this comment is that maybe token isn't necessarily the right term to use. But for now, we are going to use the term token to describe what I'm doing at the moment. Right, so that's pretty straightforward, I hope. Right, apart from, there are some things that are non-agreements on Corda, and these are what I believe pseudo-anonymous cryptocurrencies like Bitcoin or Ethereum. Let's say if you wanted to issue one of those natively onto Corda, and indeed Corda can do that, it's just we haven't done that yet, or we haven't bothered to, because no one's asked for it. But if we do, then I would argue that those tokens would not necessarily be agreements, because who's the issuer of those tokens? Well, it would be some pseudo-anonymous miner that you don't know who they are, right? So if there's nobody to sue, then I would argue that this thing does not represent an agreement. The token doesn't confer any rights to you. Likewise with those utility tokens that you see issued via ICOs, they're not agreements either, because typically they confer no rights to the owners. It's not equity, or at least they try to pass it off as not equity. The regulators might have another opinion, but again, that's out of scope for the purposes of this presentation. So I'm wondering, have I missed anything? Is there anything else that is potentially a non-agreement that could be represented on Corda? I guess you don't have to answer now, but I think this is an interesting question, because we need to make sure that we get the basics right, and this is really where I started all of this work from.
I guess for the benefit of those, so I guess implicitly you're saying that oil owned by BP in storage in Galveston that they're going to deliver to you is an agreement, but some oil in the ground or some random oil in a barrel that's just there is not an agreement you could represent on Corda.
Yeah, exactly. So clearly you can't represent physical things natively on Corda, right? You can just represent a claim for someone to deliver that physical thing to you on Corda. Therefore, if you take physical things like property, antiques, barrels of oil, I don't know, physical things that you can pick up or dig out of the ground, then yes, whilst those things are not agreements, if you wanted to represent them on Corda, then it would be an agreement. It would be a claim on an issuer that holds that thing in custody. Okay, so that's the basics really. So now, very importantly, what is the token? So feel free to debate, discuss, disagree with this, but my definition of a token is a contract state on Corda that represents an agreement with another party. But by definition, a token must contain two-party objects. If it only contains one, then it can't be an agreement, right? Because it's a unilateral thing. In Corda, we typically call the parties issuer and owner, because we have an issuer of the token. Let's say if we have a company that wants to issue shares, tokens representing shares on Corda, then the company would be the issuer and the owners would be the investors. And these tokens typically confer rights to the owners to make a claim on the issuer, for the issuer to deliver what the underlying is, or actually, this depends. So the token actually is a claim on an issuer in the case of the token being representing something that is asset-backed. So if you have a custodian holding share certificates which were originally issued off ledger, then that custodian can issue tokens representing those share certificates, and we call this tokenization. And that token represents a claim on the custodian to deliver the underlying shares. However, you can issue assets natively, so directly onto the Corda ledger, and those tokens are the legal agreements themselves, right? So So if you're a company and you issue shares directly onto the ledger, then that token is the share certificate that represents the claim on the present on the future cash flows of that company via dividends. So typically, we say tokens can be split and merged, so we call this fungibility. Maybe some might say that fungibility isn't necessarily the right term, but I think it's a term that everybody understands. And I think if we talk about fungibility going forward, we really just mean something that can be split and merged. Or if you have something, then you can represent a fractional ownership in it, potentially. Although obviously things don't have to be fungible, they can be non-fungible. And really crucially here, the last point, we want tokens to be something that can be transferred without the issuer's involvement. So this is where you have a chain of provenance in Corda. You can have an issuer that issues a token. This token passes around a bunch of owners, and then this token can be redeemed with the issuer. But the issuer doesn't have to be involved in any of those subsequent transfers after the issuance of the token. They're only involved in issuances or redemptions. Any questions so far? Okay.
One quick one for me, just because I know that Cordite has quite a sophisticated view of the issuer side. So where you said party object, you're not precluding in this intellectual construct you're creating, you're not precluding the idea that that party itself could be a composite or something sophisticated. It's just there's some way of naming the issuer without being opinionated on what sits behind it.
Yeah, that's a good point. Yeah, this is maybe a little too restrictive, just saying a party object, but indeed it could be a composite entity. It could be a little bit. There's a concept of composite keys in Corda, so you can have a public key which is actually made up of multiple public keys, and each one of those keys could be owned by a separate legal entity. So indeed you can have this concept of a composite party, or I don't know, what do you guys call them?
DAOs.
DAOs, decentralized autonomous organizations, of course. So yes, you can have those as well. So it doesn't necessarily just have to be a single legal entity or natural person as an owner. Okay. So what types of tokens can we have? This is really just a copy paste from the paper which I sent around earlier that hopefully most of you guys got a chance to read. Really, what I tried to do here was enumerate all types of things that you might possibly want to put on the ledger, and then I split them between assets and agreements. So I realize that agreement is overloaded here, but really I'm looking at the thing from the holder's perspective. So if you have a commodity or equity or currency or whatever, then it's an asset from your perspective. However, you can also see in the table that I said it's an asset of the token or receipt holder, but it's also a liability of somebody else. And I also say whether this thing can be an asset-backed token, as I mentioned prior, or whether it can be something that can be issued natively onto the ledger. I think it's pretty important to get this stuff right, because if we know exactly how to represent all types of things using the proposed model, then in a sense the proposed model probably feels right. Though if we have things missing from this table, or you think any of the designations are incorrect, then please feel free to chip in some comments either on the phone now, or drop us an email. So you can see on the table below I've got agreements, and those are typically things like OTC derivatives, exchange traded derivatives, and then there's actually loans that have been chopped off at the bottom. These things are probably non-fungible, so there will be non-fungible tokens, though you can actually represent them with fungible tokens. You just create a token where there's only one of the thing issued. And if you want to create fractional ownership in that one thing, then you just issue more tokens. So if you issue 2 tokens, then each token is a 50% share of ownership in this one thing. So there's actually multiple ways to skin a cat, if you will, with this approach. But I think that this table probably does need a bit of studying before you can comment on it. But please do have a look in your free time. So what do we have now? We have a finance module, as I mentioned. It really just implements obligation and cash. So obligation is an obligation to deliver some generic contract state type, and cash is essentially asset-backed. It's a claim on a bank deposit or a claim on a central bank reserves, however you wish to use it. But cash is quite inflexible. Yet the way it has been designed is actually quite similar to how you would design a token. So the cash contract, the cash state rather, has an amount field of some currency. It has an owner, has the notion of an issuer, and that's kind of what we want to see in a token. Except we want a token to be able to represent any arbitrary thing as opposed to just currency. And then the interfaces that we have defined in the core platform, some of you may have come across these before, but for those that haven't, contract state is the base interface for any state object on Corda, and it just makes you implement a list of parties that should be notified of updates about this particular state object. Then you've got something that's ownable that makes you define an owner. Though this is ownable state isn't applicable all the time, I think. But then we have this fungible asset state, which makes you define something that is ownable and has an issuer, and it's an amount of something. And a cash contract implements this interface. The fungible asset interface is, I feel it's a little inflexible, because you might want to have something that is fungible but not necessarily issuable or ownable. Those terms, issuable and ownable, are a little misleading, I think, sometimes. So that the semantics don't quite make sense for me. Then lastly, we have a linear state, which is typically you use it to define a state that represents a workflow or something that is non-fungible. And it's non-fungible because each linear state has a unique identifier inside it. So you can't split and merge these things. Each linear state must have its own linear ID. So we're kind of we kind of got, I don't know, 70% of the way there with the current interfaces, but I think we can still improve upon things, and that's what I've been looking to do over the last month or so. So any questions so far? Okay, so what do we need to represent tokens in the best way possible? So we need a model that's flexible enough to define any type of state. So maybe not just tokens. Maybe need to define something else that we haven't even thought of yet. So we want this model to be as flexible as possible. Then the second point, I think, is a really important one, and I'm going to talk about this a bit more later on, and that is to separate the life cycle of the token type from the question of who owns it. So currently, with the cash contracts, you have a currency object embedded into the cash state. So we can say that the token type is tightly coupled with the cash state. So yes, you can possibly change it, but it's a bit of a pain. You have to do a contract upgrade. But what if that token type needs to change? I mean, not all token types need to change, but of course some of them would do. So let's say if you have a token type which is an equity instrument, then you would expect that equity instrument to have its own life cycle. So the company that issues the equity instrument pays dividends. They might do a share split, or they might do a rights issue or something like that. And all of that needs to be managed separately from the question of who actually owns a token representing some equity in a company. I'll talk a bit more about this later. I think this is a really important idea, but I'd love to get your views on what you think about this. Third thing, it's kind of less important, but I think it's useful to guide developers in the right direction. We want to define a set of interfaces for common token types. So you might have something that is issuable that makes you define an issuer party. You might have something that is redeemable that defines some behaviors around what should happen when a token is redeemed. There are other ones. You might want to represent something that's an asset-backed token versus a ledger-native token. There's various other ones that we might want to implement. And all of these interfaces can be composed together to create certain types of tokens. And that's where you come to the next level. So the next level might be, hey, well, all equity tokens have similar characteristics, so why can't we define an interface for those? And each one of these could come with its own standards as well. But to be honest, I'm not so interested in getting into the weeds on defining interfaces for equities and fixed income instruments and loans, derivatives and things. Indeed, if you look at ISDA, they've actually done that already for derivatives. So they know the most about derivatives, so it makes sense for them to create the standards around what they should look like. So we've done a bit of work to integrate the ISDA common domain model with the Corda state model. And indeed, we've probably looked to other groups to come up with interfaces for things like equity and fixed income. But for us, we're mainly concerned about defining the high-level interfaces and types. The last thing is something that's really cool, and I'll spend a bit of time on the last couple of slides on this. And what I'm saying here is we want to be able to create token types out of existing token types. And the example I've got there is transparent mortgage-backed securities. I won't say anything more yet, but I'll get to that on the final two slides. I think this is a really important concept.
Just I know confuse people when we brainstorm this. We're not proposing to model them in the finance module, or but knowing that the model we come up with would allow somebody to model it is kind of a sign that we're on the right path with the underlying model. Is what I was trying to get.
Yeah, exactly. So as Richard said, we're not actually going to define types for any of these things. So that's for Corda app developers to do. But we just want to make very sure that the model that we come up with can cater to all of these different types of use cases. And I think number 0.4 on this slide enables that for a lot of use cases. Right, so let's start with the flexible model. So it's actually a fairly trivial change. So those of you who are familiar with Corda know that there is a fungible asset state. As I mentioned, I think it's kind of inflexible. So what I've done is I've created this new fungible state interface, and it only just defines, it makes you define that your state must have an amount of something, any type of thing. And we leave the question of ownership or issuance to other types. And I think this is an important change because it allows us to implement tokens that are fungible but not necessarily ownable. So you can have a fungible agreement, or you can also have a fungible token that is not necessarily issued, like a cryptocurrency potentially. And what does that interface look like? Well, it's pretty simple. It's just an interface with one property that takes a generic type parameter T of any type. So T here would be your token type. So the type that defines the token, the token type that this is a fungible. I've tied myself up in knots here. This is the T defines the token type, and the state that implements this interface illustrates that somebody holds a certain amount of that token type. So you have these two concepts. You have the concept of a token, and you have the concept of a token type. And if any of you guys have looked at Corda, then you would have seen that they also have this concept of a token and a token type as well. So it makes sense that you have one. Yeah, hello?
Yes, Roger, this is Jesse. Can you hear me well?
Yeah. Please go ahead.
Yeah, quick question. I mean, you're talking about the fungible state and fungible tokens. In the previous slide, it looks like the fungible asset will be extended by the fungible state. So I know on slide 7 you were representing different ways of representing assets. Where does the fungible token fit in that picture?
Sorry, that's a mistake. The arrow should be the other way around.
So the arrow from fungible state to fungible asset should be the other way around?
Yeah. So fungible asset should extend fungible state. Does that make sense? I mean, what I can maybe do is show you some. Well, afterwards I can show you the code. I've actually made the change in the code base to support this. And if if you go onto the master branch of Corda and you look inside the fungible asset.kt file, you'll see that fungible asset implements fungible state. So we've already implemented this in the platform. Hopefully that answers your question. Sorry for the mistake on the slide.
So my question was about where does the fungible token fit in that picture?
So the fungible token would sit underneath fungible state. It would implement fungible state and it would implement ownable state. So these are just the base types inside the core, and then we would implement fungible token inside this tokens SDK. Yeah, sorry if that's not clear. And then also inside the SDK we would implement token type, which is probably a linear state because it's a definition that can evolve over time.
Thank you.
Cool. Cheers. Make a note. Cool.
And does fungible asset have a life in the new world, or is it something that would be deprecated? Because if you're going to have something that implements fungible state and ownable state that you call token, then that means token and fungible asset are the same thing?
Not necessarily, because you can have a token. So the issuer will be defined inside the token type, not inside the fungible, not inside the token. So you have these two concepts: the token and the token type. Yeah. And the token is an amount of token type, and the issuer will be defined in there. Okay. I mean, I guess it's kind of similar, but I think. I mean, if it was up to me, we should just keep fungible assets. So there's no need to deprecate it. But I mean, I guess that's something we can consider another time. Okay. Right. So the next thing that we're looking to do is separate token lifecycle from ownership. So this was point 2 on the slide of changes that I mentioned. So my vision for this is. Imagine the Corda network where you have a whole bunch of token issuers. They might be issuing equities, bonds, cash, or money, and other various things as well. Claims on barrels of oil, you name it, anything. I would expect that these token issuers maintain reference data about the tokens that they issue, right? I mean, who better is there to create and maintain that reference data than the token issuers themselves, right? So imagine you're a bond issuer and you issue a bunch of bonds and they're owned by parties on the network. Well, it's your I would hope it's the responsibility of the issuer to create and syndicate reference data about those bonds. So how would that happen? How would that work? Well, the issuer would probably create what we call a data distribution group, which is a decentralized way to syndicate data around a Corda network. So you essentially create a graph-like structure to which you propagate updates to states, and then those can be recorded by all the parties that subscribe to that group. So you might want to, this bond issuer may issue just some information about the bond, the nominal amount of it, the coupon, includes maybe the bond indenture as a PDF and various other things, bits of information about this bond. Then this information can be shared about the bond. Now, clearly, this information exists in a separate state. So how do we link the information about the bond to the token representing an amount of ownership of a bond? Well, we need this concept of a pointer. We need a pointer to another state on the ledger, and I think that's an important concept. It's a concept that actually it's a feature that the people actually use in Corda today. They will put either a state ref or a linear ID in one of their state objects, and then they will resolve that state resolve that linear ID or state ref to the actual contract state that it points to. And I guess this is similar to doing a join and a SQL between two tables in a SQL database, where the linear ID or the state ref is a foreign key of a state in another table, for instance. And what we're doing here is linking the token representing ownership in a bond, for instance, to the actual underlying information about that bond. Now, the cool thing here is that the bond issuer can then unilaterally update that information about the bond. Let's say if there's a credit event, or if there's a restructuring, or they need to I don't know, pay a coupon, then that can be updated inside the linear state representing the bond, and that's completely separate to the question of ownership. Does that all make sense so far? Okay.
Maybe people who weren't on the DLB that covered it, reference states, I guess they're in, it depends on reference states, they're in Corda 4, and the docs are already written, so people can hunt around master, and they'll be able to see the docs for reference states of this build on top of it, I guess.
Yeah, thanks, Richard. That's a good point. So what I didn't mention is that this makes heavy use of the reference states feature that will be included in Corda 4. So reference states are states that can be included in a transaction. So it's essentially reference data included in a transaction. They're not in the inputs or outputs list. They can be referred to by states in the inputs or outputs list, but they are not consumed when the transaction is committed to ledger. So you can essentially have copies of a state included as a reference in many transactions without having to consume that state object every time. And then the notary checks that the data is current as well. So let's say if you want to have a reference date in a transaction, and you have an older version of it, the notary will tell you it's an old version. Then you can request the new version of it from the issuer of that reference data via, or you might automatically get it through the data distribution group that issuer provides. So yes, I appreciate there's a couple of bits here that aren't available yet. There's a very early implementation of data distribution groups on a branch in the Corda repository, and I'm working on the code for pointers, for state pointers at the moment. So that's at the pull request stage. But of course, if you think any of this doesn't make sense, you think it's mad, or you think there's a better way to do it, then please let me know. Or if you think this doesn't cater to some of your requirements, then again, please let us know.
Quick question, Roger. This is JC again. Are you providing a way to list the current ownership of all these tokens? So let's say if you are a share issuer, like a corporation, and you are distributing your shares on ledger, at some point you will want to maintain some kind of a ledger of all your shares and who is currently owning them, even after the fact. Are you providing an easy way for the issuer to list the current ownership of all the tokens?
Thanks, JC. That's an interesting question. It's also come up today from somebody else, actually. I don't know if Timo's on the line. We were having a discussion about this via email today. And it's a very interesting question. So the answer is yes, you can absolutely do that. All you would need to do is put the issuer inside the participants list of the state object. And the issuer will be, if you will, CC'd in every transaction involving that token representing some share of equity in the company. Now, then the company can then aggregate all of that data and produce a cap table, essentially, of who owns what. Now, whilst it's possible to do that, I'm not sure whether it's necessarily something you would want to do, unless, of course, the regulations force you to do it, because it makes the issuer a single point of failure, a single point of authority. It reduces the privacy of your transactions because the issuer gets to see all the other states in transactions involving their states. And there's various other things that I don't know. I'll be wary of. that would lead me to be wary of using such an approach. But it's definitely possible. Definitely possible.
Thank you.
Just as an aside, one of the things we discussed was, in a world where you're not sharing the data with the issuer, then it always brings you back to the old days of bearer bonds and coupons you clip off. You then got the point of, well, if you're due something from the issuer, if they're not being kept copied as you go along, the burden of responsibility flips, and it's now your job as the owner of the asset periodically to prove when you have the right to claim something. On demand, you prove to the owner, to the issuer, that you owned it at the time, when it went ex-div or whatever, and therefore they're obliged to pay you. So it kind of flips it on its head.
Yeah, exactly. That's a good point, actually. So let's say we have a token type representing equity in a company, and that company then declares a dividend, pushes out that update to the token type to via a data distribution group to everybody on the network. Then everybody that holds that token will be notified that there's a dividend. So how do they claim the dividend? Well, they can send their shares, their tokens, as a reference state back to the issuer, and then the issuer can tick off those states have been, a dividend has been paid in respect of those states, and then send some cash back to that party. So it's a nice mechanism to be able to deal with corporate actions and things like that, which I think is a cool property of this feature. Okay. So how does this work? This is just a simple diagram to illustrate. So let's say if you have a token and it's an amount of something. So what you could do here is you could embed the token type directly into the token, like we've done with the cash contract. So you just put the currency, GBP in there or whatever. But what you can do is have an amount of a pointer to some other state. For any of you guys that have been C programmers, it's exactly the same concept of a pointer or a reference in programming. You have a number that can be resolved into a thing that is sitting behind the pointer. Here we have this concept of a linear pointer, which takes a linear ID, and then you can use a vault query to actually resolve that linear ID into the latest version of that linear state. Of course, you can have a static pointer, which is where you just put a state ref in your token, and then you can resolve that to a contract state. But of course, you might not want to use any of that, and you might just want to embed the token type directly into your token, at which point there's no need for a pointer. But for things like equity and debt, I think there is a good reason to use a pointer to point to the definition of the token type, which can evolve separately to the token, which concerns who owns an amount of that particular token type. So that's really how it would work. And I'm working on putting that into the platform as we speak. But I think this is useful in not just tokens, but in other areas. And from having looked at quite a few Corda apps, I see that a lot of people use this pattern, and really this just formalizes the pattern. And it makes you think about some of the edge cases. For example, what happens if you can't resolve the pointer? What happens if you're using a version of the state which is out of date? For example, you haven't received the most up-to-date version of a linear state. Then this new feature makes you think about all of these things, which is quite useful, I think. Okay, so the next thing that we need to introduce are token type interfaces. So I mentioned that we want ones to represent things that are issuable and redeemable, and the interfaces themselves are actually pretty simple. It's just you'll define an issuer party. Indeed, that could be a composite party. It doesn't necessarily just have to be a singleton legal entity. Likewise, we might want to implement something that is redeemable, at which point we want to list a bunch of keys that have to be that we need a signature from, corresponding signature from, to exit this state from the ledger. Again, we might want something that's an asset-backed token. So an asset-backed token is something that's issuable, redeemable, and fungible. So we can build up from these kind of Lego blocks what different types of tokens would potentially look and behave like.
Roger. Is there any such thing as an asset that's issuable but not redeemable, or redeemable but not issuable?
So, yeah, I thought about this actually. Trust you to ask a question like this, Mike. Question: are shares redeemable? Are shares redeemable? I thought they exist in perpetuity unless there's a share buyback. No, actually, if there's a share buyback, they actually end up on the balance sheet of the company. So
they're not redeemable.
They're never redeemed.
They're not redeemable at the owner's option.
Yeah. So shares are never redeemable.
Well, not necessarily.
The joke here about homicide criminals being irredeemable. But anyway.
Thanks, James.
It's a common equity is issuable, not redeemable.
Yeah.
Something that's redeemable but not issuable. You could argue that payment for transaction fees of Bitcoin, are you redeeming the Bitcoin, but it's not issuable?
Yeah, potentially. I think
well, is it worth just merging issuable, redeemable together, and then exit keys would cease to exist, and you assume that if you issue it, you can also redeem it. I mean, does it? And then this notion of can you redeem a share? We just define redeeming in that case to mean taking off the ledger because you've done a buyback of some sort. I just wonder if it's worth having I'm not sure it's worth splitting these two concepts. I know the current data model is, but I'm not. That was probably wrong.
No, it's a good question. I probably need to think about it a bit more. I mean, you raise a good point. So, as an ex-accountant, maybe I have a tendency to look into the way tokens are actually accounted for on a balance sheet, and really that's not how people would actually use them. So technically speaking, you don't redeem shares ever. If you buy them back, they're treasury shares on the balance sheet, so they're never redeemed. But really, does anyone care about that? Probably not. So really, in how much detail do we want to go into this model? Do we care about modeling those types of concepts, or do we just brush over them?
Yeah, I mean, you could always make an issuable but not redeemable state just by blocking it in the smart contract logic, right? Just because the interface exists doesn't mean you actually have to implement it in all the other parts of the app.
Yeah.
I also wonder, there's a bit of there's a bit of archaic terminology here. Like, it claims to be redeemable, but then it calls it the concept exit in the field. And that should really be like redeem keys or something. But then, are there any cases where the issuer is not the redeemer? Just assuming there is a redeemable token.
I don't know, maybe. I haven't thought about it yet. First, what were you going to say?
My tendency is to avoid overloading interfaces with optionality, if you like. I think that just confuses things further down the line. I prefer design patterns where there are discrete building blocks that are quite clear. And there are certainly, in our use cases, we've got tokens that are only ever issued. They are never redeemed, but they're used to kind of create the unit of currency, if you like, for a certain set of economic behaviors within a completely closed system. And there is no burn, if you like. There's an issuance, but there's no burn. And you see that sort of with pre-allocated currencies and pre-allocated rewards and stuff like that. So I think I personally feel comfortable with this kind of degree of precision because it's less confusing to me, for what it's worth.
Interesting. And there's another confusing one because Mike and Roger, you were using slightly different meanings of the words. Maybe you need to go back and think about semantics, because when I think about redeemable, I think about redeemable as the option of the owner. Mike was talking about redeemable by the issuer, so we need to figure out whether we need to distinguish between those two concepts.
Yeah.
Do you guys envision being able to split these tokens?
Yeah, absolutely. So anything that implements fungible token is splittable and mergeable, assuming that the token type is the same. So if you have a 1 of token type X and a 2 of token type X, you can merge it into 3 of token type X and split it up as well. And you'll see there's an interface here that I haven't actually explained, but it's called tokenizable asset info. and that makes you define a default fraction digits field. It tells you how many decimal places that particular token should have. So in the case of Japanese yen, it's none. The smallest unit is 1. But in the case of pounds, it's 2 decimal places, for instance. So that would need to be integrated in there as well, to make sure that you can add and subtract these tokens and split and merge them. Okay. So yeah, this is very much up for discussion. This is probably not something we're going to do straight away. And indeed, you guys may have implemented some of your own interfaces or have your own type hierarchies in mind, how you'd like to model this stuff. And I think it's quite fun to consider these types of things. So I don't know, if you want to give it some thought and let us know, post on the mailing list, then that would be very much appreciated. And I'm not particularly opinionated about how we do this. It's really just about making it as easy as possible for you guys to create token types. Okay, so composable token types. I think this is quite fun, actually, because what it allows you to do is model things the way they actually exist in reality, right? So let's say if we want to take electronic money. What actually is electronic money? Let's say if I start a company which is an electronic money issuer in the EU law definition, so I can create a token which represents a claim on a bank deposits in some bank. Then how should I represent this? Well, with this model that we've got here, we can represent electronic money as a claim on a GBP bank deposit at Barclays, which is also a claim, which is in turn a claim on the central bank for an amount of central bank reserves denominated in GBP. If we were actually to do this properly, then we would probably have some kind of weird recursive relationship at the very end, and I don't think you would actually be able to terminate the hierarchy. But we have to end it somewhere, and I guess we do that with the definition of pound sterling, and we just assume that there's nothing on the asset side of the central bank's balance sheet. And GBP is of course created by fiat of the government, likewise with any other fiat currency. So we just assume that that's the lowest common denominator in any kind of currency universe. And I think this is quite cool because it allows you to represent things as they actually exist in reality. Now, this might be a bit esoteric. Some of you might not care. Maybe a lot of people don't care. You don't even need to do this, but I think it's cool that you can do it because you can have these very expressive token types. And of course, you can make your token type depend upon types created by other issuers as well. So you don't have to depend on your own ones. You can, instead of having instead of inlining the definitions like we have here, you could actually have the definition being a pointer to some state. So really what we're doing here is we're telling the token owner whose liability this token is. So initially it's the e-money issuer's liability, then it becomes Barclays' liability, and then the Bank of England's liability. It's the ultimate liability of the Bank of England. So I guess it's quite cool to think about this in my view. But even more cool, I don't know if you guys have seen the Big Short. There's this scene where Michael Barry here is a fund manager, and he's trying to figure out what is inside a mortgage-backed security note. And he figures out that it's just a bunch of rubbish mortgages backing the notes. And that was in, 2007? But what if those bonds were issued in 2018? Then you could actually create a token type which defines the collateral pool for each one of those notes in perfect detail. So what's actually going on here? Well, we've got SPV with assets and liabilities on their balance sheet. The assets for their SPV are, of course, loans and cash. You collect the receipts from the mortgages. So, but what is a mortgage? Well, it's a loan which is secured by some property, bricks and mortar, whatever. And then we have the liabilities of the SPV, which are notes like A, B, C notes, equity tranche, etc. So if you are an owner of a C note and you want to figure out what's actually in it, well, you can look at the token type and see, well, it's composed of, I don't know, 50 mortgages. Here we've only got 2. And then you can look at each one of those mortgages to see what the details of it are. Then you can even look at the collateral as well. So I think that's pretty cool. And representing mortgage-backed notes is just one application of this. I think you could probably the sky's the limit for what you could do with this approach for modeling tokens. And then Michael Barry wouldn't have to do this because he would just know what's in the bond straight away, and there would be no mortgage meltdown. So I think this is quite cool. That's actually the final slide of the presentation. I hope it gave you a good overview of what we're looking to do. Just to summarize very quickly, we're looking to create some new interfaces and types that exist within the core platform. We are looking to separate the lifecycle of the token from the question of who owns it, and we're looking to consider interfaces for token types themselves. And then we're looking to make sure that this model is flexible enough such that you can compose these token types together. And I spent a fair bit of time thinking about this. Although I could have got some of it wrong, and I mean probably some of it isn't spot on yet. I think it's certainly going in the right direction. And if you guys have any questions or thoughts on what I presented, then I'd love to know. So over to the floor for any questions.
Roger, can you hear me?
Yeah.
This is Mujtaba from EY. I think I'm trying to just grapple with the concept, but keeping an insurance hat and where we are designing InsureWave, right? This is far away from us, where we would like to see how we could support our clients utilize a tokenized payment solution, okay, which is one of the modules that we will look into next year. Looking into that, right, there are 3 key building blocks that you spoke about. One was around the concept of fungible states, tokens, and token definitions. Second was reference states, and the third one was data distribution groups. Yeah. So from an outside-in view, for me, for this functionality to be available, these 3 things will need to be available in the platform or the product, right? So my simple question is, what are the timelines we are looking out for these capabilities to be available so that we can leverage in some of the use cases that we think is useful for us?
Okay, thanks, good question. So reference states are available now on master, and they'll be released in Corda version 4. The fungible state and the pointer types should also be like 99% sure that they will be available in Corda version 4 as well. The only thing that won't be available in Corda version 4 will be the data distribution groups feature. The actual SDK for tokens itself will be released on a different cadence to the core platform itself. So there'll actually be more frequent releases. So you can think of the tokens SDK as a library that sits on top of Corda. It doesn't necessarily have to be released at the same schedule of Corda itself. So the only thing that's really missing is the data distribution groups. Though there are ways to handle syndication of token types without data distribution groups. And perhaps we can talk about that offline.
Maybe we should include a sample or something.
Yeah, okay.
And Corda 4, we're targeting this year. There's a few stop ship items that we have to get done, and if they take longer, then we'll have to postpone the ship. But the ambition is to get that out this side of the new year, January the latest.
Yeah, thanks for that. This is really interesting to us as well. Thanks.
Cool, thanks. Any other questions? No? Okay, well, thank you very much for listening, everybody. I hope you found it useful and informative. If you do have any questions or would like to speak to me about any of this or anyone else, then please just either drop us an email or a message on Slack. I guess you know where we are, and we'd be happy to discuss, happy to take any of your requirements. And yeah, I guess I'll leave
that was a great job, Roger. In a totally unbiased viewpoint, I thought that this was the best DRB I've ever been to. So thank you very much.
I have one question.
Thanks, Todd. Cheers, James. Yeah.
Just to denigrate my contribution to the meeting further, when is Corda coin?
When is Corda coin?
Okay. That was a joke.
I think James has been serious. He really wants to see Corda coin.
Thank you very much.
Thanks, everybody.
Yeah, thanks.
Okay, everybody. Thank you.
Thanks, guys. Good job.